So welcome everybody to the UVM Extension Hemp webinar series. We've had a number of webinars on this time, Thursday at noon. Thanks for joining us today, especially on such a sunny day, but hopefully some people are taking a break and having a lunch break. So today the focus is on CBD post-harvest with an emphasis on drying, and we have three great panelists who are sharing their expertise with us. To kick off, we have Chris Callahan from UVM Extension. He's an ag engineering specialist, and we'll talk about how you dry the stuff, how you keep it dry, and what's the process, how do you store it. And then we're moving on to Gretchen Schimmelfennig with the Resource Innovation Institute. Her focus is on helping hemp growers with resource efficiency and why that's so important, the extent to which you can save energy costs. Heating can be expensive, so if you can reduce your energy costs, reduce your water usage, use those resources efficiently, you can really keep your production costs down. And we know from a recent survey that a lot of farmers are really worried about this, production piece, keeping the cost down, making sure you have quality product. So that will be the emphasis of her talk. And then we're moving on to Landon Wheeler, who's from the Division of Fire Safety. And in particular, he's going to focus on, well, making sure the stuff doesn't burn up when you don't want it to. So what sort of risks are there with drying practices, making sure your mechanical equipment is working well, doesn't burn out on you, you don't have something short-circuiting and setting things on fire. So how you use equipment appropriately, how you keep it maintained and working well for you. So I think we can get going. Chris is ready to go with us and will be sharing his presentation. And thanks to Catherine, who's pulling this all together, and also Heather Darby, who will be moderating the Q&A towards the end of the session. So we'll get started now. And as we go along, if there are questions you have, either type them in the chat if you're online, or the Q&A, and we'll deal with those towards the end of the session.
Thanks. Susie, are you able to hear me okay?
Yeah.
And you should be now seeing an outline of the presentation, which differs a little bit from what Susie just outlined. Gretchen and I will be jointly covering the first piece, an introduction to drying, with a focus on hemp. We also have Lauren Morlino from Efficiency of Vermont, who will be covering some efficiency incentives and practices that are relevant to this area. And then we will wrap up with Landon's presentation about some safety specific considerations. And with any luck, we'll have time for Q&A. I do want to note, I will be posting the presentation on the short link at the bottom of this page, go.uvm.edu/hemp drying. My guess is that Heather's team will be posting, recording it as well. So, and I'll wrap up with contact information for each of us at the end of the presentation. So thanks for having us. This has been a great opportunity for the four of us to get together along with some other partners to really think through the post-harvest handling and drying and storage aspects of this emerging industry in Vermont and beyond. So we hope you enjoy what we've put together. So as I mentioned, Gretchen and I will start out by just talking about some drying basics. And I'm with UVM Extension Agricultural Engineering, and Gretchen is with the Resource Innovation Institute. We're going to talk a little bit about what we're actually doing when we say we're drying, and what we're doing when we say we're curing. And those two terms are sometimes used interchangeably, and we're going to try to introduce some differentiation here to help everybody. A big part of what we're going to talk about is air and water and how the two play together in the form of humidity. I'm going to then talk about some drying approaches. We've categorized them in three buckets: ambient drying, heated forced air, and then some closed dehumidification systems. I'm going to talk a little bit about the pros and cons of each, and we'll wrap up by setting Lauren up for talking about some of the efficiency aspects of this. And as we go, we'll also be highlighting some safety aspects to provide a foundation for Landon to speak in more detail. So what are we doing when we're drying anything? This is actually a picture that I used when Heather and I used to work more on hops and drying hops and trying to move that industry along. And actually a lot of my experience and information that I have is for hemp is being drawn from my work in hops. What we're trying to do is really make sure that we pass relatively dry air over the crop we're trying to dry. We want to be, that enables moisture to be driven from the crop, from the plant matter into the air. That dry inlet air becomes humid because we've moved the moisture from the plant matter to the air. And then typically want to get rid of that, either that humid air or the moisture that's in the air. And that's where the systems tend to diverge a little bit. And we'll talk about how they're a little bit different. So over time, as we remove water from the crop, we're reducing the weight of the crop, and we're lowering the moisture content, or MC. One of the things that's easily overlooked is just how much water we're talking about here. So typically at harvest, most agricultural crops are harvested, that we dry down, most are harvested at about 80% moisture content. It means 80% of the harvested weight is water, and we're trying to dry down to generally 10%. So we're removing about 70% of the weight by drying. And so as a quick example, for a ton of material, that's about 168 gallons. So there's a fair bit of water we're trying to remove from this crop in a relatively controlled way. Gretchen?
So how you dry really depends on what you're doing to your product and what the end product is desired at your market. So with hemp, we often talk about different markets related to biomass, extracts, and smokable flower production. And so that's where the processes often diverge. For craft cannabis production, we're often talking about curing, wanting to dry at a lower temperature, maybe allowing humidities to stay higher so that we retain visual or aroma qualities related to terpenes, or we just want to make sure that we're resulting in a lower temperature dry. With drying, which is often more what we see with hemp, we're going to tolerate a higher temperature. We're going to maximize how quickly we can dry. So if you're trying to avoid a longer drying time, oftentimes you're choosing a system that is going to go at a higher temperature. So I just really wanted to bring up the fact that the way that you choose to operate the different systems that we talked today is really going to diverge even with the same system, depending on what your product is.
The other thing I forgot to say is we're really focusing, the four of us are really focusing today on biomass and smokable CBD hemp. We're not really going to get into systems or practices that are focused on, for example, fiber hemp or oilseed hemp or seed saving or genetics. So we really wanted to focus the conversation mainly on the CBD hemp markets and practices. The other point I wanted to make is it's important to remember that the air temperature is not necessarily what the product temperature is that you're drying. So typically you can have a higher air temperature, and because we're evaporating moisture from the product, that cools the product and the air close to the product. So, you know, when we talk about temperatures, the product temperature can differ from the air temperature. We mentioned that what we're doing is bringing the crop from a relatively high moisture content to a relatively low moisture content. And in talking with a number of growers, it struck me that not everybody really is measuring moisture content. It's often done by feel or by observation. So I wanted to just highlight a couple of resources and a little bit of feedback from growers. The growers who have been measuring moisture content that I talked with were using moisture meters. And those usually typically designed for grain, measuring grain moisture content. And those are nice when you have a uniform mix of a material. They're a little bit tricky to use for a crop like hemp because you have a stem, leaf, flower, and unless you really almost pulverize that, you're not going to get a very representative sample. And there may be some calibration challenges as well. So a relatively simple and inexpensive way of doing some moisture content measurement is actually a dried weighed sample, where you take a sample of a harvested sample of known weight, you dry it in a dehumidifier or in a controlled way in a microwave in short bursts of time until it no longer changes weight, and then you know you're bone dry. And the difference between those two weights is what moisture weight was. we have this online calculator, and also there's a video guide at the short link listed here. Just go.uvm.edu/moisture, which can help you out. And you know, so there's a lookup table, and then there's also a YouTube video that walks you through the process. So that's moisture content. That's the water that's in the crop. The other place that we have water in these systems is we're moving water into the air, and that's humidity. That's when the liquid water that's in the crop turns into vapor and is actually in gas phase in the air, vapor phase in the air. And this is an important part of these systems because the amount of humidity and the amount of water vapor in the air drives how much more can be added to the air to dry the product and how quickly it can be added. And so humidity is the amount of water vapor that's in air, and relative humidity is how much relative to the maximum air at a certain temperature can hold. And so, and that maximum amount of water vapor that air can hold is totally dependent on temperature and pressure, but mainly temperature in our systems. And it's important to remember that it is relative. So air at 68 degrees Fahrenheit, for example, when compared to air at 41 degrees Fahrenheit, can carry 3 times the amount of water vapor. And that's what's shown in the figure here. So warmer, drier air will absorb more water vapor, and it'll absorb it more quickly than cooler, more humid air. And this is, again, becomes really important when talking about drying and curing. I wanted Gretchen to take a moment to highlight a resource they have.
Yeah, so if you're not interested in diving deep into engineering terminology, I definitely understand that. But when working with these controlled environments, whether you're cultivating or drying, it's good to get a basis of understanding of some of the terms that your engineering team or your contractors may use, and the terms that we're going to continue to use as we talk about the differences between these systems. So if you want to get a basis of understanding, I recommend our free resource. It's related to cannabis cultivation, but the terms about thermodynamics that we're going to talk about today, like relative humidity and dew point temperature and things like that, that's all in there. It's all free, and we just provide it to give everybody a level playing field when they get started considering systems and planning projects, as well as understanding the efficiency options that they have to consider. So we're here to help. I'm just a national resource. I work in Vermont, and I hope that you guys find some value in this in getting a basis of understanding. So thanks.
It's a well done guide. I've seen a lot of HVAC guides in my time, and this is really well done, Gretchen. Thanks for pulling it together. So when we're talking about humidity, it's important to know that we can measure it. And there are electronic relative humidity sensors. I know many folks use those, things you might get from a weather station or just measuring temperature and humidity in a home. Those are fine when you're between 20 and 80% relative humidity at sort of normal room temperature. When you start to get beyond 80% humidity, I found them to be very inaccurate, and actually I found them to fail, electrically fail. And so I have spent a lot of time focused on humidity measurement and management in storage systems, in particular cold storage. And I tried to use these electronic sensors quite a bit, and really just gotten super frustrated because they just don't have the life or accuracy. And so I tend to fall back on something called a sling psychrometer, and it's in the upper right corner here. It's I think $70 from Ben Meadows Forestry Supply Company. And what this is doing is measuring 2 temperatures that really are what's used to determine relative humidity. It's the dry bulb temperature, which is what we normally just refer to as temperature. And then there's something called a wet bulb temperature. And so there you can see that there's a white cotton wick on one of the thermometers, at the bottom of the thermometers. That gets saturated with water. And when you sling that through the air, or more carefully put it in front of a fan that's blowing air so you don't break the thermometer in where you are, that temperature gets depressed compared to the dry temperature. The evaporation of water into the air cools the bulb of that thermometer. And the difference between these 2 temperatures is what actually tells us relative humidity. Relative humidity is just an easy way of carrying this information around as one number. I found this to be the absolute gold standard for knowing relative humidity accurately, and it's a relatively inexpensive way of doing it. It's a lookup table or an online calculator, and you know your relative humidity with really good accuracy. this motivated me to actually develop a better electronic psychrometer, and that's what's shown in the lower right-hand corner, and that's available from a Vermont company called Vermont Energy Control Systems. Some growers have noted that when trying to, for example, dry in a barn or something, overnight they find condensation, or they see signs of condensation, such as molds or mildews. And so condensation is a challenge when we're drying, and what's happening here. We'll get into some of the overnight or the day to night differences in ambient conditions, but we're going from a relatively warm, relatively dry set of conditions, air conditions, to relatively cool, relatively humid conditions, which is going to bring us closer and closer to something called the dew point temperature, which is exactly when the water vapor that's in the air starts to condense out as liquid water. And so that's what's happening. And so we'll talk a little bit about what to do to avoid that. But when you're doing ambient drying or barn or greenhouse drying, it's important to remember you need both ventilation, so exchanging the air from outside to inside, but also circulation, circulating the air inside so that everything is seeing essentially the same conditions. So let's talk about some of the drying approaches. Gretchen and I put our heads together and sort of broke it down into these three categories: ambient drying, which you might know as hanging product in the barn or laying it out on greenhouse benches; forced heated air, sometimes referred to as plenum dryers or rotary dryers; sometimes a heated ventilated room; or if you've worked with hops, you might know it as an oast. And then lastly, there's a dehumidification process or approach, and that's using a refrigeration cycle to actually intentionally condense water vapor out of the air to dry it and then reheat it and send it back to take up more moisture. And talk about each of these individually. We didn't really get into, we didn't at all get into absorbent drying or desiccant dryers or vacuum drying. We're trying to focus on the things that are most common that we see. We can talk about some of the more advanced systems if we have some time. So ambient drying, on the left are a couple of examples of greenhouse drying. This is from Howard Prusak, where you can see some plants hung on greenhouse purlins or ties, and then some laid out on greenhouse benches. On the right-hand side is from Andy Chamberlain, some barn drying in a super clean, super orderly, organized barn that's well ventilated and circulated, and with the air that's well circulated. Some of the pros to ambient drying, well, it's simple. You hang it, and it's pretty low tech. There's not a whole lot of technology or controls involved. Most farms have space available in empty barns to do this. It's relatively inexpensive or even free. It can be high capacity, but generally is lower density because you're hanging whole plants, and they need room around them for air circulation. No additional heat input necessary, so it's a minimal greenhouse gas or carbon footprint consideration. On the downside, you're subject to ambient conditions. We'll talk about that in just a minute, but you really are depending on the outside conditions to do your drying, and that can limit both capacity, drying capacity, how long it takes to dry, and the resulting quality. And so if we look at average conditions this is from Montpelier, we can see that most of our humidity is middle of summer, and that's what we all know and feel. And then we get into winter, and it gets really dry, right? And this all sounds good. So October, for example, when we're normally drying, looks like it's not too bad. So let's take a closer look at October. September coming into October, the humidity drops dramatically, and we know this by our own personal experiences. So this looks really good, right? We have low humidity. We're able to adjust temperature a fair bit. But if we look at the daily cycle of temperature and humidity, this is on September 28th and October 20th using 30-year weather history. So this is the average conditions for these particular days over 30 years. You can see there's a fair bit of variability, right? And we know this. We all feel this, right? The temperature gets cooler at night and it's warmer during the day. But we may not always be looking at relative humidity, and that's a key thing when we're talking about drying. What is the humidity? What's the water vapor in the air? when we're trying to dry, particularly when we depend on outside conditions. So this is what drives the condensation that you might see in ambient drying, and it also is what drives the fact that it takes a bit longer than some of the other approaches. Forced heated air plenum type dryers on the left-hand side are some Cureco tobacco dryers that John Satz has used in the past in Brandon. And so these are propane fired. They're made to dry tobacco leaves. So some of the infrastructure or the design is actually quite relevant. You set a dry bulb temperature and a wet bulb temperature in that control unit there, and it automatically heats when it has to and brings in fresh air when it has to dry. So it heats to raise the temperature by firing the burner, and it brings in fresh air to drop the humidity so you maintain your conditions. On the right-hand side are from Dylan Robinson at New England Hemp Commodities, some of the self-built propane unit heater plenums that they've made for handling a fairly high volume of product. You can see propane unit heaters there. They're the shiny metal things on the far side of the wood construction. When building something yourself, and Landon I think is going to talk about this, want to make sure you're paying attention to whatever the clearances are, the combustion clearances are on the appliance, on the heater itself. Most of these heaters come with installation manuals that say they need to be a certain distance from combustible materials. So Landon will get into that later on in more detail. So with forced heated air plenum systems, it gets you a faster drying rate, of course, but it can be at a higher temperature. And so you do want to make sure you have good controls and that you're measuring air temperature accurately with a calibrated thermometer or thermostat so that you're controlling really well. You can modulate it for lower temp drying, but again, it all depends on the controls and how well the burners, for example, the heaters can be modulated. This is you can use a variety of fuels to do this. So you're not locked into fossil fuels. You could use biomass. You could use electric heaters. This could even be done with a heat pump system. But it needs to be sized to the need. We put this in more of a moderate operating cost category. Not the most expensive to run, but it's not free, right? It's not ambient drying. On the downside, initial cost is going to be more than an existing building. So there's some work involved. There's some materials cost involved. The systems can be complex, and you're going to need ventilation and circulation of air to make this happen. And if you do use fossil fuels, you are introducing some greenhouse gas or carbon impact that you may want to consider. And there could be, if you have a control issue or you haven't really designed the system well, you may have a quality loss because of either high temperatures or over drying. These systems are faster and hotter generally.
So the most sophisticated form of drying that can be done is with a heat pump refrigeration cycle. I just want to, at the beginning, say that everyone has lots of these types of systems in their home. Refrigeration cycles are used whenever you have a compressor and a condenser and evaporator. And so we have in our refrigerator, we have on the back of the refrigerator, one half of a heat pump system, and on the inside, the cold part. Similarly, a window air conditioner. And then, you have a standalone dehumidifier. That's also technically a heat pump system. It's just one way. Some of the systems Lauren's going to talk about later are the more conventional now heat pump systems that we use to refer to things that perform HVAC in lots of different types of buildings. And they're reversible. So they can go in cooling mode and they can go in heating mode. And nowadays, even some of them, even for home use, have like a dry mode. So we just got a schematic here to explain how these systems can both be reversed to cool and dehumidify, and also a picture here of a Quest dehumidifier, a kind of a typical operation. If you're going to use a traditional way to dehumidify hemp product. Some more high performance options may afford you increased energy efficiency, so lower operational costs than perhaps a traditional dehumidifier. If you look for or work with partners to find a more energy efficient commercial purpose-built dehumidifier, you might save energy. Even if the first cost is higher, you might be able to get a rebate. And then likewise, if you consider using a cooling-based or primarily just dehumidification-based system using a family in the heat pumps, so, you know, an air-to-air heat pump, some of the systems that will be discussed by Lauren later, you might get rebates from not only Efficiency Vermont, but also from your electric utility. So if you click the next slide, Chris, you can see that these systems are going to have, on the cons list, they're going to have higher first costs. And they're going to have potentially higher operating costs because you're going to be using electricity to either, if you want to dehumidify and dry at a higher temperature, heat, or again, use electricity to cool. So if you had been using fossil fuel to dry previously or using an ambient drying system, your operating costs are going to increase if you decide to use a, you know, commercial dehumidifier or a heat pump system. However, there are lots of pros to this. If you're going for a craft cannabis operation and you want good controls, these systems are more sophisticated and they have options for energy monitoring. They also, if you're looking at your grid mix and considering carbon impacts, they can have a lower greenhouse gas impact, especially if you're currently doing a forced air heated with fossil fuel drying based system. They can be sized to need, and like we said earlier, they've got efficiency incentives, and you may have improved quality by being able to retain terpenes and that visual quality that you want if you're looking for a certain smokable product. So with all of these systems, I would say, going back to my first slide, is it depends on what product you're looking for in the end. It depends on what your goals as a business are, whether you're interested in maintaining operating costs that you currently have, reducing them over time. If you're able to work on a higher first cost project, but work with utilities to reduce that first cost, you might benefit from considering a more sophisticated system. But I always would like to say that if you have an existing system, there's always ways to improve how it currently works. So Chris, if you want to go to the next slide, in wrap up, I'll hand it over to you, but I would say no matter what system you have, I would highly recommend reaching out to your efficiency utility, because there's always an opportunity that you know, Lauren will highlight. For example, any fan or motor might be able to be retrofitted to be variable speed. So Chris, take it away.
Yeah, thanks, Gretchen. I think one of the key things we all talked about was, you know, just one of our interests in doing this webinar was making sure you're aware of us as resources in our organizations, and to reach out, but reach out early, because we do tend to get a lot right in the middle of drying season, a lot of questions and inquiries. So the sooner we hear from you and can help, the better. Again, Gretchen, you really drove it home. The key here is knowing or planning for where you plan to sell and to whom and what they're after, so that'll influence how you dry. The other thing is, this is a fairly seasonal and short-term use, and so oftentimes it's done somewhat ad hoc. But I think the other key thing that Gretchen and I wanted to really reinforce is this, you know, we know how to design these systems to work well. And so if you're running into issues, reach out and we can help troubleshoot and plan ahead and plan for a system that's actually going to work well for you. So we have a couple other speakers here to talk, and then we'll do some questions all together at the end. The next speaker is Lauren Morlino with Efficiency Vermont. Lauren, you able to unmute?
Yeah, can you hear me okay?
Yep.
Awesome. Yeah, so my name is Lauren Morlino. I work as an Emerging Technologies and Services Manager at Efficiency Vermont. If you don't know, Efficiency Vermont is the statewide energy efficiency utility. We serve all Vermonters with the exception of the city of Burlington, where we work alongside Burlington Electric to provide seamless energy efficiency expertise and rebates. We also work closely with the electric and gas utilities to maximize value to Vermonters in the grid. Vermont Electric Co-op, Burlington Electric, and Green Mountain Power helped to develop this presentation and have been wonderful partners in the indoor and outdoor agriculture sectors in Vermont. So how we can help. Efficiency Vermont can offer technical assistance by talking through technological solutions and cost-benefit analyses. We can also review design ideas and provide feedback. For large, complex projects, we have energy modeling capability in-house as well. We can provide connections to our efficiency excellence network. Efficiency excellence network members are independent contractors committed to providing their customers the highest level of professional energy efficiency services. This network is comprised of experts in advanced technologies and building sciences that make buildings more efficient and affordable to maintain. They are also trained to understand and consider important health and safety measures that are key to any job. And the types of contractors that we can connect you with include HVAC, new construction, commercial refrigeration, insulation and air sealing, as well as electrical. We can also assist with thermal shell considerations and of course offer incentives on certain technologies, which I'll get into on the next slides. So in terms of technologies, there are incentives available for efficient fans or VFDs on fans, Energy Star dehumidifiers, and heat pumps used appropriately in drying applications. Fans and HVAC equipment like heat pumps must be evaluated on a project by project basis. What matters is that they're applied appropriately, and that will vary based on the building area or type or amount of product, type of product. So for example, as Gretchen mentioned, with hemp, there are some drying techniques or sequences that are better for extraction versus smokable product. These systems must be designed and applied appropriately given the moisture loads that must be wrung out of the air. Efficiency Vermont can help with cost-benefit analysis for energy savings if a customer is comparing solutions, for example, whether to go with a high-temperature propane heater versus a centralized dehumidification system with heat pump technology. We can also connect you with contractors or engineers in the Efficiency Excellence Network who can size and design your system appropriately. Fans, heat pumps, and control incentives will all be custom, so you should call us for more information on those and to get your project enrolled. And you can submit online for dehumidifier rebates, which actually have a $50 income eligible bonus right now. Next slide, please. Building envelope is really important in these locations. A building envelope is the physical separator between the conditioned and unconditioned environment of a building, including the resistance to air, water, heat, light, or even noise. Air sealing is really key in these spaces. You'll want to avoid rehumidifying the space and adding moisture back into your product. So if the air is leaking in from a more humid outside environment than it is inside, then you'll need to use more energy because you're having to condition the space coming in as well as dry the product. This tends to be especially problematic at night when the humidity level rises. And a leaky building can reduce your equipment capacity and capability. For some general air sealing recommendations, use durable sheet goods like plywood to cover larger voids. Plastic can be iffy because it can get holes really easily. Use spray foam, caulk, or liquid flashing products for smaller voids or cracks. And air will move from the bottom up like a chimney. So make sure you're sealing at the bottom of where your walls and your slab or your floor meet, as well as the top of the room. Insulation is not as important in these spaces because usually we're seeing customers dry around September or October, which are more neutral months. So the air sealing is really the important part here. Blower door tests are a way to depressurize a building in order to understand where it leaks and also give you a better picture of the overall energy performance. With many of these buildings, doing a blower door test up front may not be possible, but it is possible that we could perform a blower door test after the air sealing is done, and that would lead you to the process of getting rebates for your thermal envelope upgrade. incentives are only available if mechanical drying or heating is being used, not for passive drying, because there wouldn't be enough energy savings there for incentives. Next slide, please. And finally, I wanted to mention the electric utilities again. Gretchen went over this nicely, but there are some benefits to electrifying your drying operation, including reducing your carbon footprint. In some cases, it could be a lower cost, and also increased flexibility and precision control. In addition to the Efficiency Vermont incentives that I mentioned so far, the electric utilities also have incentives available through their carbon reduction programs, also known as Tier 3. Tier 3 opportunities could include switching to electric resistance heat or installing heat pump technologies. It's important to connect with your electric utility early and often during your project. They can help you determine whether you're eligible for incentives, if you need access to 3-phase power, or just help you connect a new service location. And that's it for my portion of the presentation. I bolded and highlighted this, the telephone number for the customer support line. It's that 888 line. That's your best bet in terms of getting an engineer assigned to your project and some technical assistance and starting the process for incentives. Happy to, obviously stick around for some questions or be contacted directly as well. But the customer support line is a really great resource.
Thanks, Lauren.
Thank you.
Gonna roll right into Landon's section, and like I said, we'll do questions at the end. Landon?
Yeah. So, like most safety-related items, we come last. And Chris, if you wouldn't mind going to the next slide, that'd be great. So, the Division of Fire Safety, and how does safety play a role in this big picture? Well, the state of Vermont does have rules and regulations that cover public buildings. And the definition of public buildings can be found in our state statute. When we're dealing specifically with agricultural buildings, if you're renting property or if you have employees are going to be some of the triggers for being defined as a public building. And what does that mean? If you're defined as a public building, that means that a state fire marshal will probably be involved in your process if you're going to install new fixed equipment, or you're going to fix the envelope of your building and make it airtight, or if you're going to start increasing your amperage for your service. Are all some really good examples of where the Division of Fire Safety will get involved in regards to making sure that it's done in a safe way. As everybody's talked about, these are improvements to help farmers and processors better prepare a product for sale. And losing that sale could be a big financial loss. Losing the building that the product's in could be a big financial loss. Having somebody injured on a job site or in an emergency, such as a fire, would be a big loss. So that's why the Division of Fire Safety can play a pretty significant role in some of these projects. The process is really simple for us. If you have a plan, we ask you to submit it in a permit form, and you can, at the end of the slides, you'll see access to our website where you can get those. And we go through that process and what you want to do, and we help you find a safe way to meet your objectives. We can go to the next slide, please. So a lot of the major hazards that are associated with specific drying are, number one would be electrical. There's a lot of electrical equipment when we start talking about adding heat to a building or removing moisture from a building or circulating air throughout a building. And that usually takes some form of power to complete. So making sure that we have equipment that can service that amount of power draw is pretty important. Use of materials such as vapor barriers. Not all plastics can be put on walls, and not all plastics are safe to be used as wall material. We can help you with that. And as Lauren said earlier, spray foams are a great option to close up some holes but they do have restrictions and rules that have to be followed to use spray foams in public buildings, and we can help you with that. Stored combustible materials is obviously, that's what you're doing. You're storing combustible materials and you're actually lowering the moisture in those materials. So how to store them and what is a safe way to keep them stored is definitely something that we would help with. Blocked exits and lack of exiting. When we're talking about passive or ambient drying methods, a lot of these are being done in barns, and barns can typically have limited exits, and evaluating those to see if they're safe for use, or if a door needs to be added, or if a horizontal sliding door can be utilized as an exit it's pretty important. Heat and moisture removal is definitely something that's important for any building that's being utilized to reduce the water levels in these hemp products. It's not just removing the moisture from the product itself, it's also removing the moisture from the building that the product is in. Having moisture build up in a building, you'll have mold, you can have building failure, structural elements can fail over a period of time if they're constantly being attacked by humidity. So evaluating the processes that you're going to be utilizing and working through them with you as the customer is definitely one of our goals. We have a lot of very, very smart farmers and a lot of very smart people in Vermont, and a lot of people have come up with great ways to invent ways to remove moisture levels from their hemp products. And we've worked with quite a few to reach their goals and objectives. There is a very limited amount of UL listed and tested equipment that's designed specifically for this process. So working with our clients and working with engineers is definitely something that we do on a regular basis. Next slide, please. So here's some examples of some inappropriate electrical. These are all real scenarios. These are all real pictures. Extension cords are a big no-no. Any of your high electric demand equipment, such as dehumidifiers, large fans, heating appliances, they should all be plugged directly into a wall outlet that can provide the correct amperage for the equipment. Drawing more power than is available. If you see a receptacle surge protector with 7 plugs in it and they're all supplying dehumidifiers, you're probably overloading circuits. It's very important to know what the limitations are for the circuits in the electrical system that you have and that you're using. Homemade appliances, cords, and electrical equipment. This is very common. You can actually buy everything that you want on the internet to do lighting systems, new fans, even extension cords, but that doesn't mean that they're safe or that's a safe method. Again, undersized electrical services. If you're a farm, you may only have 100 amps or 60 amps servicing your barn building, but with the amount of electrical equipment that you're utilizing for fans and dehumidifiers may far exceed that. So having a service or an electrical supply that's going to be able to service the equipment that you're going to utilize is pretty important. Heat generation from electrical resistance. The more electricity that you pull through a wire, the more heat that's generated. And some fires, even some in the pictures you can see in the center, that's caused by drawing too much current through an electrical receptacle. Next slide, please. So back to use of materials again. Coating walls with plastic, it can be done, but the right plastics have to be utilized. An example of wrapping a barn with saran wrap is not a good idea. Stored combustible materials. Storing materials so that you have clear paths and exits to be able to leave the building in case of an emergency is pretty important. Spreading your product out enough so that it's not creating additional risks and hazards or fire hazards with electrical equipment or in close proximity to heat producing equipment such as a gas-fired furnace or modine type heaters is very important. So I always recommend following the manufacturer's recommendations anytime that a heat producing appliances being utilized, but never less than 3 feet from a heat producing appliance, or even a dehumidifier or a fan should always have 3 feet of clearance around it. And as product is packaged, you know, piling product up on itself, it does two things that are negatives. It puts all of your product in one location, so if something starts to happen there, you're going to damage and possibly ruin a lot of your product, say if it catches fire. But on that same note, it makes it a whole lot harder for firefighters to fight the fire because they'll have limited access to be able to get to the seat of the fire if it's either piled high or piled close together. So separating your product and having some aisles once you start packaging or you hanging product is a very important life safety item. Next slide, please. Means of egress, I've mentioned it a few times already. Having clear exits that aren't locked from the inside are very important for you or any employees that you may have or firefighters that are responding to the building. As you can see from the pictures, you know, none of these exits are really accessible. And if behind all that bulk storage on the bottom picture, you know, if the exit was there, firefighters or employees would have a very little chance of getting to an exit if there was an emergency within that building. So keeping exits clear, unobstructed, and maintained in an operable way is definitely a very important item. Next slide, please. Timing and planning. As you heard Chris and Lauren and everybody else that's spoken today, you know, timing is very important. So if you have a plan and you want to start a commercial process and you're a public building by definition, by all means, reach out and to the Division of Fire Safety and somebody will get you in touch with me. My contact information will be on here. I always tell people the faster that you get involved with me, the faster I can issue a permit or complete a site visit or do a walkthrough of a building that somebody wants to utilize. You know, every project is different. The scale of all the projects are different. Some projects have increased in scale quite a bit in a single season. And as Chris and Lauren have also talked about, you know, you're going to see what works for you in regards to processing, and adding equipment is inevitable. And adding equipment in a safe way is definitely one of my main objectives. So get in touch with us as early as possible, and we'll help you through any of the processes that you want and that you need to go through. Next slide. So here's my contact information. And my name again is Landon Wheeler. And by all means, reach out if you have any questions. I am also a great individual for you to call or to email if you want to find out if your building is a public building. I can help you walk through the state statute and the definition. And by all means, you know, I'm an educator first, and I will always be an educator way before I'm an enforcer. So please feel free to contact me. Thank you.
Thanks, Landon. Thanks, Lauren, and thanks, Gretchen. Catherine or Heather or Susie, I guess it's back to you for some Q&A. We do have one in the chat box. Actually, it looks like two from Keith, which I'm happy to start with unless you have other plans.
Yeah, I think go ahead, Chris. I think answer that question about the moisture. That would be great.
Yep. So Keith asked a question about, can anyone comment on how much air exchange might be needed when drying with dehumidification approaches? Keith, that really comes down, the way I would approach this is start by knowing or estimating how much product, wet product you have going into the space. Second point is having a sense of how quickly you feel you need to dry that down. Those two things combined tell you how quickly you need to remove a certain amount of water, right? We know the amount of product, moisture content change, that's the amount of water we need to remove. If you're using a dehumidification process, dehumidifiers are rated by pints per day that they can remove at a certain temperature. So that's the third piece, is how much moisture is the dehumidifier going to take out of the air. If that all lines up, you're pretty good in terms of air exchange. If it doesn't, in other words, if the dehumidifiers aren't going to do the full job that you need them to do, that's when you need to start looking at air exchange. And the way to determine the amount of air exchange is to actually look at the humidity of the air outside versus what it's going to be at about 80%, which is where the drying in the room is going to sort of max out. And you can compare the moisture in those two air samples, if you will, to get a sense for how much CFM you need. It's a calculation. Both Gretchen and I can help you with doing that. Keith's second question had to do with, does anyone have any experience using water activity meters for assessing moisture content, and how to relate water activity measurement to moisture content? Yes, so water activity is it's a slightly different animal from moisture content. Water activity is really, you can have water in a product that is not readily available to, for example, evaporate. And so it's often used in food processing, like if you think about a cracker or a cereal, water activity is really critical in delivering something that's got crunch. They want very low water activity cured products, such as like salami and prosciutto, cured meats. Water activity is also very important there. It's a measure of how much water that's in the product is actually available, not bound up in sugars or salts or other chemical compounds. And so there is a relation between water activity and moisture content. It varies by product, and I'm not sure there's a good correlation on hemp or components of hemp quite yet. I'd have to dig into that. I hope that helps.
Okay, thank you, Chris. And we have a question about people hanging hemp in barns. Are there issues with roof collapse?
I can take this. So this is a very barn specific question. And is there risk? Absolutely. As soon as you start loading something with a live load that wasn't necessarily designed to have a live load, you can have risk. But I'm going to give you an example of somewhere where it may not be such a big deal. You know, if you have a hay loft above that would typically support hay, and you're going to support hemp to dry hemp, it's probably negligible. Actually, the hemp is probably a lot lighter than the hay bales would ever be. So it wouldn't be necessarily an issue. But on that same note, if you had a newer barn with a light wood frame truss system that was installed in the barn, and you are going to hang multiple rows or stacks of hemp tightly packed, this could necessarily be overloading that truss system. And truss systems are highly susceptible to failure if they are overweighted, especially with point loads. So to answer your question, it would be barn specific, and there probably are very safe barns to do it in, and there's probably barns that aren't really designed for it.
Okay, and we have another question, thank you, Landon, related to drying in September. How often can one get adequate drying in September and early October by simply hanging in a pole barn?
There's a lot of drying, other drying processes or crops that are dried at that same time, and it can be done without significant quality loss. Just based on outside conditions, the trick is to make sure you actually have some intentional circulation of air. The trick is making sure that the conditions in the pole barn are actually well mixed. What you want to avoid is stratification, having different conditions at the top that you have at the bottom. And that's going to happen naturally unless you put a fan in there or a blower to mix the space up. So I think you can get adequate drying throughout September and October. It's a matter of it's going to take a little while, so it may not be as timely as you want it to be, and there may be some quality loss as a result of that, depending on your market. And the other thing is making sure you're stirring the space up.
Okay, so if you maintain ventilation and circulation, you should be okay with ambient conditions and keep out humidity by reasonable sealing. Okay, going back to the chat, Landon, it's a question about, are fire marshals generally available now? Early in COVID, they seem to have been reallocated. We couldn't get a response for months. So I guess this is, you probably have a lot on your plate. Do you have time to actually deal with these queries?
Yes. So I apologize if somebody didn't get in touch with you, but please feel free if you have questions to reach out to me, where we do our best to get back to everybody in a timely manner. our fire marshals are pulled in many different directions because we wear a lot of different hats. And this, as important as this is, this makes up a very, very small portion of our overall responsibilities. But my contact information will be on here, and I am the hemp representative for half of the state, so feel free to reach out to me.
Thank you, Landon. And we have time for one final question. What impact will a dirt floor have on drying?
It's going to be a moisture source, most likely, and it may also be a mold source. You know, again, doing anything you possibly can to, first of all, make sure there's no additional storm water coming in to saturate that soil, and thinking about your project in phases and maybe planning for closing that space in and addressing the dirt floor. That'd be my suggestion. The other thing is just from a hygiene perspective, you're working on a product here that is eventually intended to be consumed. So maintaining hygiene should be a priority.
Okay, I think we're closing in on our hour. So I want to thank all our panelists, but also to let our audience know that each of our panelists can be reached by email and by phone. So you can ask your questions. And again, ask your questions early. For those of you that are online, we have a quick question for you to answer online. If you could answer that one question poll, that would be fantastic. And also to let you know that next week, same day, same time, August 13th, we have Mike DiTomaso from the agency talking about hemp sampling and testing. We're coming into that critical phase. So I hope some of you can also join us for next week. And this webinar will, not only is it recorded, but we'll also have the presentations available on UVM Extension's website. Thanks for joining us. And thank you to all our panelists. Thanks for making the time.
Thanks for having us.
Thank you.
Thank you, Chris. Please take a second, too, before you leave, to hit the quick poll. I can see it went up. Looks like everybody's leaving. All right. Thanks, Chris, and everyone. That was really great. Very informative. We're going to be drying some hemp soon, so good info.
Good.
All of our auto flowers are ready, getting close to harvest. So.
Would you mind sharing whether you choose to dry ambient with hotter temperatures or with cooler dehumidification system sort of approaches?
My audio is really bad, so it's really hard for me to hear you, but I think, were you asking me about our drying data that we have?
Or just how you choose to dry. Just anecdotally, I was curious how, based off of what Chris and I talked about, where did you see yourself in the presentation? Do you dry like one of those ways?
We've dried both, like we've hung whole plants, but mostly we harvest them, you know, and buck them down to the flower buds with some leaves and then put them into a dryer at about 105 degrees Fahrenheit. And we have compared air drying, like an ambient temperature, to 80 degrees in a dryer with a fan to 105 degrees in a dryer with a fan. And we really haven't seen any difference, at least in CBD concentrations. There hasn't been any degradation. We see more, I would say we see more, I think, degradation over time, depending on how people store the hemp once it's harvested and dried. So, you know, it's very similar to hops, Chris, where people are putting them in cold storage and they're properly kind of packaged. There's no reduction in CBD over 180 days, but it's very, you know, sort of leaving it out. Even if it's in the dark, then the reduction can be quite substantial just after a few months. So I'm kind of worried about the longer term storage, especially as people have hung on to product and, I think people just haven't really, you know, figured out the best way to do that. So.
Yeah, storage is a whole other piece of the quality retention equation for sure. Thanks for sharing.
I mean, we try to, we don't have enough room to hang everything to dry, although that would kind of break, you know, it would give us more time, I guess, to get things harvested. But because we don't have enough space and we have these experiments, we try to harvest everything green, basically the flower bud, and dry it within, you know, basically 24 hours so that we can move it out and make room for the next experiment. So, yeah.
Thanks for sharing.
Cool. Yeah. All right. Well, I'm going to go back out and play in the hemp, I guess.
See you later, everybody. Feel free to reach out. Take care.
Have a great day.
Thanks, everybody.
Thanks. Thank you, everybody. Bye.